So you click Add to Cart, and then what happens? It's not magic, right? Look, no matter if you're headed into tech, finance, marketing, whatever, understanding how stuff actually gets made, that's like a secret weapon for your career. It's the engine that makes the whole economy go. So today, we're going to pull back that curtain and get into the manufacturing concepts you've just got to know. Let's start with this question, because it really gets to the heart of everything. Have you ever wondered why you can spec out a brand new laptop, totally customized, and have it in your hands in like a week? But if you want a custom car, you're waiting for months? The answer isn't just, oh, cars are more complicated. Nope, it's all about a massive strategic choice that a company makes way before a single part is even made. It's this epic tug of war between giving you exactly what you want and getting it to you super fast. All right, so here's our game plan. We're going to start with the big strategic choice. Then we'll see how that choice actually shapes the factory floor. After that, we'll crunch some simple numbers to see how these decisions are made. And we'll wrap up by looking at the blueprints that guide the whole production. Okay, let's dive into our first section, the strategic choice. And yeah, before we even think about machines and assembly lines, we have to start here, in the boardroom. Because this one decision, it literally dictates everything that comes next. And it all boils down to a single critical question. When does a product stop being something we're making for inventory and start becoming something you specifically ordered? And that question brings us to this key idea. It's got a bit of a jargony name, the customer order decoupling point. But don't worry about the name. Think of it like this. It's the exact spot in the production line where the company stops guessing and starts building for a real person. Everything before that point is based on a forecast. They're just making stuff they hope you'll buy. Everything after that point is triggered by your actual order. Where you place that decoupling point, well, that changes absolutely everything. And this chart here, it shows you that trade-off perfectly. See those upside-down triangles? Those are the decoupling points we were just talking about. Now watch what happens. The further to the right you push that point, the faster the customer gets their stuff, which, is great for us as customers. But look at what happens to the company. Their investment in inventory, all that cash just sitting there in a warehouse, it skyrockets. That is a massive financial risk. So it's this constant, delicate balancing act. So this balancing act really gives us 4 main strategies. First, you've got make to stock. That's your grocery store. You walk in, grab a box of cereal off the shelf. Instant gratification, zero customization. Then there's assemble to order. Think about Dell computers back in the day. You'd go online, pick your hard drive, your RAM, and they'd snap it together for you. Pretty quick with some choice. Move further down the line, and you get make to order. This is like getting a custom suit made. They don't start cutting the fabric until you place the order. And at the far end, you have engineer to order. We're talking about building a Boeing jet here. They're literally designing and building it with the customer from scratch. All right, so the big strategic choice is made. You know whether you're a make-to-stock company or an engineer-to-order one. But now, what does the factory actually look like? How do you set up the physical space to make that strategy come to life? Time to head out onto the factory floor. The key to figuring that out is this fantastic tool called the Product Process Matrix. Seriously, this is the go-to framework for managers. And it's actually pretty simple. Along the bottom, you have product volume. Are you making just one? Or are you making millions? And then on the side, you have product variety. Is every single item unique, or are they all exactly the same? The whole goal is to find the perfect layout that matches up with where your product falls on this grid. So, let's start in that top left corner. If you're building something huge and one of a kind, like a house or a massive ship, you use what's called a project layout. I mean, you can't exactly put a skyscraper on an assembly line, right? So the product stays put, and all the workers, the materials, the cranes, everything comes to it. Okay, what if you're making more stuff, but there's still a lot of variety? That's when you use a work center, sometimes called a job shop. The idea here is to group similar machines together. So you'll have a cutting department, a welding department, a painting department. The product kind of winds its way through the shop, going only to the stations it needs. It's super flexible, but it's not the fastest way to do things. Now, a really clever solution is the manufacturing cell. I love this idea. It's like a mini factory inside the main factory. You take all the different pieces of equipment needed for a specific family of products, and you arrange them together, often in a U-shape. A small, dedicated team works inside that cell. It's kind of the best of both worlds. You get some of that assembly line efficiency, but you keep a lot of that job shop flexibility. And then, of course, we have the one everybody pictures when they think of a factory, the assembly line. This is the classic Henry Ford model, perfect for making tons and tons of the same thing, like cars. The product moves down a line, and at each station, a worker or a robot does one specific task over and over again. It is unbelievably efficient for mass production, but flexible? Not so much. Finally, at the most extreme end of the scale, we have a continuous process. Think of this as an assembly line that literally never, ever stops. It runs 24/7. This is for things that don't come in pieces but actually flow, like oil being refined or chemicals or even beer. The volume is just astronomical, and the product is a totally standard commodity. Okay, so now you've got all these options for your factory layout. How on earth do you decide between them? Do you go with a super flexible work center or a crazy efficient assembly line? Well, this isn't something you just go with your gut on. You actually use some pretty straightforward math to figure out which option is going to be the most cost-effective. It's a tool called break-even analysis, and it's really just 3 simple steps. First, you lay out all your options. Let's say you could buy a part, make it on machine A, or make it on a fancier machine B. Step 2, for each of those options, you figure out your fixed costs, that's the big upfront investment, and your variable costs, which is just the cost for each individual item you make. Then, step 3, and this is the magic part, you find the exact number of units where the total cost of 2 options becomes exactly the same. That number is your break-even point. It's the decision point. And a graph like this just makes it so easy to see. Let's walk through it. That red line is your buy option. See how it starts at 0? No upfront cost, but it's steep because you're paying more for every single part. Then you've got your 2 make options. The lathe has a higher starting point, that's your fixed cost, but the line isn't as steep. And then look at that big machining center. It starts way up high, a huge investment, but it's so efficient, the cost per part is tiny, so the line is almost flat. The most important parts of this whole graph are where the lines cross. Those are your break-even points. So let's look at that first crossover point. At 640 units, the cost to buy the part and the cost to make it on the simple lathe are identical. So what does that tell you? If you think you're going to need fewer than 640 units, the decision is a no-brainer. You just buy it. Don't even think about buying a machine. It's simply not worth it. Okay, but what if you know your demand is going to be way higher? Now we look at that second crossover point, up at 2,000 units. That's where making it on the simple lathe costs the exact same as making it on that big, expensive machining center. So if you're pretty sure you're going to make more than 2,000 units over the product's life, that huge upfront investment in the fancy machine actually becomes the smartest move. Its super low cost per part means you save a ton of money in the long run. All right, the big decisions have been made. We've got our strategy, we've got our factory layout. Now it's time to get down to the nitty-gritty. How do you make sure the people on the factory floor can actually build the product perfectly, the same way every single time? Well, you need blueprints. But I'm not just talking about blueprints for the product. You need blueprints for the entire process. And it all starts with what's called an assembly drawing. You've probably seen these before, maybe in an IKEA manual. It's that classic exploded view that shows every last screw, bracket, and panel and exactly how they all fit together. This is the master guide for the product itself. Okay, so from that visual drawing, you then create an assembly chart. And this is basically the step-by-step recipe for building the thing. It spells out the exact sequence. Step 1, attach this part to that part. Step 2, inspect the connection. Step 3, add the next piece. It's all about making sure things happen in the correct order, with no exceptions. But to really get to the next level, you need a process flowchart. This is where the magic of improvement really happens. Why? Because this chart doesn't just show the work being done, it also shows all the time spent not doing work. Things like moving parts around, waiting in a queue for a machine, or just sitting in storage. In the world of manufacturing, all that stuff is considered waste. It's time that adds zero value to the customer. And the whole point of this flowchart is to make that waste painfully obvious, so you can go after it and get rid of it. So let's boil this all down. What are the key things you need to walk away with? Just 4 points. First, strategy drives everything. That decision about the decoupling point sets the stage for all the rest. Second, form follows function. Your factory layout has to be a perfect match for your strategy. Third, let the math guide you. Use break-even analysis to make smart, data-driven choices, not just guesses. And finally, number 4, if you can't map it, you can't improve it. You have to visualize your process to see the waste and then get rid of it. And look, here's why this stuff is more critical now than ever before. All these concepts, process, flow, strategy, these are the timeless building blocks of how things get made. But when you take that solid foundation and you combine it with the incredible tools we have today, like AI and machine learning, you don't just get a little more efficient. You unlock the potential for truly game-changing innovation. So the real question I want to leave you with is this. Now that you understand the fundamental building blocks, what are you going to build?